One of you guys, thank you for the email. I'm not going to call you out by name. But last night I got an email saying, Mr. Holloway, I'd really like it if we did more factoring stuff. So I got you. Or I'm lying. I don't know. Nobody sent it, just so you know. Like, nobody gets thrown under the pretend bus. Nobody emailed me, but we're going to add a little bit to our factoring. Remind me real quick. We're just going to take a step along the way. The first person to speak is the first one, like you to go first. If I'm trying to factor something, what's the first thing we always check? And then what? And if it's a binomial, what are you hoping to find? The difference of squares. Now, in everything factoring that we have done, it has all been around quadratic stuff. Now, whether it's truly quadratic or not, because a lot of those ideas apply in different functions also, but pretty much everything we did with factoring was x squared, right? Now, just to show you that it applies to other situations, do you guys remember the shortcut? With the leading coefficient is 1. If I do this, and I'm going to make this even nicer, x to the 4th plus 2x plus 1. And I'm going to make that 2x squared. Do you guys think we could factor this, even though it's not a quadratic? If we run through the list all the same, like it's a trinomial, and we can check, does this kind of have the same thing if we have a square and a 1? Is that same relationship existing with the exponents here? Okay, so if we wanted to factor this, and I'm trying to decide if I want to use the shortcut or not. We might as well. There might be something else we can do, but we're going to use the shortcut. Can you guys find factors of 1 that add up to 2? It's 1 and 1, right? Now, if we were to do this, it's 1, or it's 2, sorry. Oh my gosh. It's a 1 and then a 1 and a 1. Okay, what's my first factor? Instead of just writing x, how do we get that first thing? Because if I do the exact same problem here, x squared plus 2x plus 1, we know it just starts with an x here, right? What does that one start with? 2x?
Yeah, I'm getting lost a little bit.
So do you agree that on this one, when we use the shortcut, it's the same numbers, do you agree it's going to be x plus 1 and x plus 1?
Yeah.
Why did we choose x here instead of something else? We just brought down the square root of it, is really what happened. Can you do the square root of this one? So x squared. Do my magic numbers still work the same though? Do you think it's still x squared plus 1 and x squared plus 1? Does it still work?
No, because wait, 1?
I just want to check. What's x squared times x squared?
X to x4.
Okay, so we're good. What's 1x squared plus 1x squared?
X squared.
And what's 1 times 1?
1.
1. So does the same factoring work even though it's not quadratic? I think so, right? We just did it. Now, it has to do with this pattern here. Now, unfortunately, or fortunately, depending on how you feel about factoring, quadratics are only a very small part of all the possible polynomials, which means there's bigger stuff. And we've already talked a little bit about some of those. But in 3.3, we are going to be talking about the idea of polynomial identities. Now, the concept of identities, you guys have obviously seen some identity stuff before, whether you're aware of it or not. And I'm just going to try to remind you of where you've seen these words before. When I hear identity in math, I legitimately don't think of Algebra 2. I don't even think, I think of way higher level math because a lot of the time this is something that is really important. And luckily we have identities in our math. Does a number exist that I can multiply, for example, 5? 5 times what is still 5?
1.
So that means that 1 is the multiplicative identity because we get the same thing out. What number is the additive identity? So in different contexts. So 5 times 1 gives me 5, says that 1 is the identity. What number do I add to 5 to still get 5? 5 plus 5 is 10. 0 would work though, right? 5 plus 0 is still 5. So 0 is what we call the additive identity. Now, that's the only place that I think you would have seen this word ever show up in mathematics, is with the additive and multiplicative identity. Now, as we go through, there is another way to think about these. So we're going to actually just define in mathematics, when we're not talking about just an operation, we're going to talk a little bit about identities, but I'm just going to define identity. I'm putting so much stress on the T sounds and it sounds weird when I say it. There was a commercial years ago where they were talking about how everything was $9.99, and I kind of like it. And you probably didn't even catch what I said. Did you understand what I said? 99T9. Like it's just $9.99. Like it's just a weird emphasis. Anywho, back to identity. For our purposes, and you'll see it this year. If you take pre-calc with me, we'll see it again. An identity is simply going to be thought of, in our purposes at least, as a statement, and realistically it'll probably be an equation. So I'm just going to put equation in parentheses. That is true for all values of a variable. Now, there's more that we could say here if we wanted to be more specific. You might mention about the domain of certain things, but we don't have anything weird happening with ours, so we're good here. Now, we can see identities, and we're about to see some identities, and you've actually already seen a bunch of identities already this year, but I'm just going to show you a couple of them that you guys can do, and you probably don't even recognize that it's an identity, but let's check, and I'll show you that you can do this in general. If I have two numbers, and it doesn't really matter what they are, A and B, let's just say that they're some numbers. If I take A times negative B, no matter what the numbers are, I'm going to get negative AB. Is that always true no matter what A and B are? With the exception of 0, but you wouldn't have a negative 0, right? Okay, this can be thought of as an identity then, because it's always true, and we might put that caveat or that one little thing that says except 0, but it's always true. What about, are there others that we've seen? And certainly there are. You might not remember them off the top of your head. When we did the perfect square trinomial, we always did the following. And this is going to be really general, but if we have 1x squared, I'm not going to do that one. We'll look at that one later. Okay, the one that's really nice, I'm just going to write it up here. For our purposes, where we've seen these identities, is with factoring stuff. And there's one that comes to mind. Factoring and identities. Now, it's hard to come up with a general rule or an identity for some situations. Like the shortcut, it works if the leading coefficient's 1 and you do AC that add up to, like, there's a whole bunch of stuff that goes into it. But we have seen some that are really nice. And I want you guys, I'm going to write that nicer. Just remind me one more time. We stopped at binomials a moment ago, but what's after difference of squares if we're factoring? You check if it's a trinomial. And if it's a trinomial, what do you hope to see? Perfect squares are nice because they factor really easily. And then what if it's not a perfect square? You hope the leading coefficient is a 1. And that is awesome if it works. What if it's not a 1? What do you try? And what if grouping fails? The quadratic formula. Now, that whole list is really only made for quadratics or things that have some power leading degree is twice as big as the middle one. So x squared and x, or x to the 4th and x squared, or x to the 6th and x cubed. They would all work there. Now, for our purposes, we're going to look at a couple identities. The first one is one that you've already seen, and we've dealt with it a bunch. It is the difference of squares. It turns out that this is an identity. And we used it yesterday, I think, to do some big ugly multiplication, right? Cool. If I have the difference of squares for all values a and b, if I give you a squared minus b squared, can we break it down or factor it? How? So you take the square root, and what does it give me? A minus b, and the other one is a plus b. Now, the cool thing is it doesn't matter at all what numbers a and b are. If you give me any two real numbers, this will work every single time. And we use that to our advantage constantly. Like we use it over and over with the difference of squares. What we're going to do today is we're going to expand out that idea of factoring just a little bit. And I'm going to be honest. These ones, if you happen to get them memorized just by what we're doing and just by doing them, that's awesome. But this is one of the few times that I'll say, if you don't memorize it, put it on your note card, be able to use it. But you do not have to commit like the brain power to memorizing it, as long as you can use this. So we are still going to stick in binomials because normally we just move on, right? Now, what's cooler than a square? Cubes. Square roots are a good thought, Kian, and I do agree with you, but we're not in a polynomial if we have ugly powers like that. So we're going to give ourselves real quick the difference of cubes. Now, as we look at this, it is going to be a cubed minus b cubed. This is how it looks. And I will put a star. I'll make sure that this is clear. Now, walk me through just what happens. And I know it can be kind of a challenge. We're doing it left and right. How did I go from a squared to a, though? I took the square root. This is not a square anymore, right? It's a cube. How do you think I'm going to go from here to this first thing? I'm not a square root, though. A cube root. A cube root. Now, we never do it with squares, but I assume you've seen this. If I talk, why do we call it a square root?
Because when you square it, it gives you
Yeah, you're right.
it's half.
I wouldn't say half. I like what you said. By itself. When you square it, it gives a number. We never write anything here, right? If I just have it, it's a square root. Is there a number here, though, that we don't write?
2.
This is what a square root is. We just don't write it. If I want it to be a cube root, it's a 3 here. That's it. So check it out. We're going to go ahead and start and hope it works out the same. I'm going to simply take the cube root of both of these. So cube root. What is the cube root of a cubed? A. And notice the sign is minus. I'm going to stick with that for now. A minus, what's the cube root of b cubed? B. All right. Now, I'm trying down here with these, like this is pretty much the step-by-step stuff. We'll do examples of this here in a minute, but I want us to see if we can't think stuff out. Okay. I know that whatever I put here, this first part of the FOIL should probably give me a to the third power. Do you guys agree with that? So it's going to get messy for a second, but it's very much my hope that we'll be able to tie it in. If you want to spend a second to get some colored pencils, I'm cool with that. Like, I'm going to color mine a bunch. If I wanted to get an a cubed, I just have to take this term, and I need to have it here but squared. A squared. Because now if I did this multiplication, and I know that there's a bunch more stuff coming, but if I just started the distribution and I did a times a squared, what would it give me? Which is what I need, right? That's where we're trying to get. Now I'm going to skip this middle term for now, and I'm going to think about the very last part of my distribution. It needs to turn into a b cubed, right? So what do you think I should do with this value? So I just take this and I just square it, and I just write b squared right there. Okay. The big question becomes the stinking middle part. Right now, and if you have all these marks and the arrows are lining up, I squared. That's all I did. I just squared a and b. So here I took the cube root to get to a and b, and then I just took those numbers again and squared it for my second piece. Now, this one, we need stuff to fall out at the end. Now, as I'm looking at this, I don't usually do this, but I'm going to really try to draw the attention. I'm just going to give us a rule and we'll verify it works. I'm going to take this sign, but I'm going to change it opposite. Okay. That's the first thing. Notice, if it's a cubed minus b cubed, I stick with a minus on the first one, and then I have a plus here. Like, it's weird that it changes, but it changes. There's a reason to it. We can go into it if you'd like. This last one. If I were to multiply AB, can you guys tell me what it is? If you multiply this and this, that's there. And I need your guys' help. I can do opposite, and we can say product, and we can just sneak them in here. AB. AB. Opposite product. And with the lines, that might make sense. Have I lost anybody? Like, I'm trying to show a bunch of stuff just so we can remember a way to get it.
Do you think maybe it would be easier if you wrote down each step?
So there's not really a ton of steps. Unless you want to do the proof, which we can. I'm just trying to make sure we can see the parts.
So, wait, how did we get from a minus b parentheses to a squared? How did we do that?
We took these terms. I said a squared and b squared. So I just take whatever number this is, a and b, and I square them and put a at the front, squared, and b at the front, squared. And then this one is just their product, and we change sign. So we're gonna we'll get practice, and if we need to come up with a way, I don't have one ready right now. Is realistically, Lucy, the only reason that I didn't immediately say yes. I don't know that the order really matters as long as all this stuff happens. If we need an order, I'll work on one. If we need it at the end of the hour, I'll have one for tomorrow. Okay. So, and that's okay, because I don't really care if you remember necessarily, but I do care if you can use it, because you get a note card. Now, this one, is there such a thing as a sum of cubes? Sorry, sum of squares. Like if I have a squared plus b squared, does that simplify? Are you sure, Kian? Not unless we want to get into the imaginary numbers, which, do you guys want to? Okay, so we don't have that one. Sum of squares never shows up. However, cubes don't care. You can take the cube of a negative number without getting weird. So we also get the sum of cubes. And here's the cool part, and we'll be able to tell really quickly whether or not you're okay with this idea. Only one thing changes about this. If I'm writing the sum of cubes, I'm going to write a cubed, and then what instead? Plus b cubed. Okay, so here's what we're going to try to do. Using just what's written here, I want you to write it very lightly in case we have to erase it and kill it. But I want you to see if you can apply this exact same strategy where I took the cube root, I used the same sign as this and this. Like, I want you to see if you can tell me what you think the sum of cubes is going to be based off of just what we have here. I'm going to give you like 30 seconds. It's okay if you're wrong, but I want to see if we can generalize it or not. We do the exact same thing. Our sign just happens to be different. I'm going to give you guys like 30 seconds just to see what we come up with. So let's check it.
Plus.
Love that, and great catch, by the way. And let's close the parentheses.
Yeah.
And then, no, you're good. I'm sorry, I'm not trying to rush you.
No, you're good.
Love it. What do you think comes next? Almost love all of it. Like, only one little part I don't like. If we look at this, I get a cubed, right? When I do the multiplication.
Mm-hmm.
What if I do the last part? Do I get b cubed or minus b cubed?
Oh, minus.
So what do you think that should change?
So this.
Good. There's two places. It'll change here, and it'll change here. Because this sign, and I didn't draw this one, and if you want to add a mark, notice those match. Cool. All right, so a little bit more time. Are we cool? I mean, I'm cool, but do we need more time to do the problem? Okay. David, what do you think? What goes in this first set of parentheses? Love it. David took the cube root of both of these to get there. And he happened to just use the same sign. Okay, I'm not going to put all the marks on this one because it looks nice without it. In this term, Jade, what's the first thing we need? A plus B? So pause. What's the last thing we need, Desi? At the very end to get, this is going to give me an a cubed out of the deal. Good. Okay, there's only one little thing that changes. Notice these signs changed, right? That sign did not, neither did this one. Beatrice, what would your gut tell you on this one? Minus, and the sign changes. Now, this is the rule. It's the same rule for both of them. Now, what we see happening, and you guys, I don't think you've ever seen this, when you get time to the cheat sheet, I would write these two as one together. And if you want just a single one that doesn't have all the ugly writing, entirely up to you. You guys have seen the sign plus or minus, right? Have you ever seen the sign minus or plus? Right here? Because we always, so there's two ways to answer that. One of these will hopefully work. If I think about at the very end of my multiplication, whatever I multiply this by, I need to get a b cubed out of the deal. So I know that it's b squared just because of that. Because, and you want it to be minus, I assume? If it were minus, let's just see what would happen. If that were a minus instead, what's b times negative b squared? What's b times negative b squared? Sorry, like that. What's a positive times a negative? So we would have wound up with minus b cubed here, but we need it to be a plus. Yep, and the other one gets sorted out because we have this minus here is why. Okay, now if you want it as a singular rule, this is the sum or difference of cubes, and I'm going to switch color, completely up to you if you want to have this one. If you want it as one rule, like I would on a cheat sheet, all that we need to do is instead we'll just say a cubed plus or minus b cubed, and we'll just see what it expands to. And now there's only one weird situation here. The first sign doesn't match, like minus here and minus here, or plus here and plus here. It always matches, right? So it means our first one is going to be a in the same order, plus or minus b. Notice top to top is plus to plus, and bottom to bottom would be negative to negative. Okay, this first term, no matter what, is a squared. Here's where it gets weird. If it's a minus, this sign changed to a plus, right?
Yeah.
Or vice versa, if it was a plus, the other one is a minus. And I see that change. Because the way that we've written this, top to top, bottom to bottom, always applies. Plus or minus here, plus or minus, so that they match. This one is the opposite, and it's weird, but we use minus or plus. So because now notice, a plus becomes a plus b, and then a squared minus, and I'm just going top to top the whole way through. And it's weird to see this because I don't think, I was surprised when you said yes, you had. We might have done this in here, but I don't recall doing it. So if you ever do see it, it's just telling you the order matters every time. But it's still AB and plus B squared. These are the two new rules that we get. Now, as far as using these, it depends. We're going to see some techniques later on that are nicer to use in this, but let's do a little tiny bit of factoring with these guys. Okay. There was a thought for a brain break. I'm trying to remember what it was, though. Did we talk about it in here? I don't have enough. We're not taking a 25-minute brain break. Otherwise, I'd be down. Did you say chess? Oh, did you hear my follow-up comment? Not today. And you know how to play. Anybody have an idea, or are we just going to keep kicking? So we'll go really short. We'll do a quick brain break if you guys need one. But I'm going to make you stand up and move a little bit. All right. So we're going to use this, and we're going to do an example right off the bat. So here we go. We're going to add a little stuff over here just to help. I'm going to say here's a number n and n cubed, just because I want to be able to get a few of them. Because you guys have a few powers of squares ready. I don't think that you're as good at cubes. No offense. We'll see. We'll see. Desi, was that you that wowed? So you're okay. Like I'm going to mess with you here for a second, but it's not in a mean way, I don't think. It's not mean from my perspective, I guess. What's the biggest cube you know? Like, do you know 7 cubed? So that was a bad guess, but I like that you're talking. Oh, 1,000 cubed. I see. What's 1,000 cubed? That's not true. You had 9 zeros. It's going to be 10 to the 3 times 10 to the 3. 1,000 cubed is a billion. Yep. So let's not start at 1,000. What's 0 cubed? Okay. What's 1 cubed? Okay. What's 2 cubed? 2 times 2 times 2 is 8. Okay. What is 3 cubed? Beatrice is killing it. What about 4?
4 times 4 is 64.
Okay. Realistically, up through 5 is what I would suggest you have. You don't even have to you don't have to memorize them, but you have to do a lot less thinking if you have memorized. Well, we'll see how far we can go until we struggle. 125. 6. I only remember this one because of I had a professor, my favorite professor in all of college. His name was Dr. Morehouse. But he would always make the same lame joke. His room, like his office, was in Ross Hall, and it was room 216. And you would always tell us that you'll never forget it because it's a 6 by 6 by 6 room. This is 6 cubed. This is 216. 7 is harder for me. 343. Because it's just 49 times or 50 times 7 and then subtract 7. I legitimately don't know 8, but I bet it's 256. Or 512. One of those two. It's 512. Right? I don't know. 512. 64 times 8. 8 times 60 is 480. Yep, we're good. And 8 times 4 is 32. Yeah. Okay. I don't know 9. I had no interest. Realistically, up through these ones is what I would say kind of in here somewhere. I don't know where. Okay. We're going to keep these up on the board for now. And you guys are going to help me factor the following. All right. So we'll do one together, which we're going to do a kind of ugly one together. And then I'll give you an easier one. Cool. So let's do 8x cubed minus, let's say, 125. Now, as we run through, there's something weird that might happen depending on if we stumble upon the example or not. I'll caution you guys just in case it does happen if the examples we make up. I'm going to run through the list. Always the first thing, what do we check? Is there a GCF between 8 and 125? So we won't count the cube as a GCF, but the fact that you recognize them as both cubes is awesome. Okay, so if there's no GCF, we kick forward. Is this a binomial? Is it a difference? Is it two square numbers? Try again. No, I'm not trying to trick you, but the language here is important. They're not squares, they're cubes. So to get this, to factor this thing down, we're just going to use that identity that we wrote a moment ago. What is the cube root of this number? 2. And how about the x cubed? X. Okay. This sign, do I use the same sign? Right here, already opposite? It's opposite in this middle one, right? Same sign here. So if this is minus, what should we use? Minus, what's the cube root of this? 5. There's our first piece. Now, just to really make sure that this lines up, if we're using this formula, notice we're using the minus, so I need a minus here and a plus here. They switch on the next one. But we have A and B identified. This is like my A part right here, and this is the B part. Okay, when we kick forward, I'm going to switch color just for the second part. We take this first term, A, and we do what to it? Don't distribute yet. We're just looking. I went from A, and then I did what to that number? So what's A in this case? So I heard 3 different answers. 2 what? 2x. What's 2x times 2x? 4x squared. Okay, notice the minus here. This is the only weird part. What do we do with the sign? We opposite. So now we're adding. Now, when you do this next part, notice I didn't ever once say that b was negative 5. I just said b was 5. Okay, what's a times b if we forget about the negative? What's 2x times 5? 10x. And then plus, how do we get the last term? We take this number and you square it and you get 25. Okay, we are well on the way. And it's just by using this formula. Yell, just so you can see, if you have trouble working out cubes, here's the first 8 of them. It's really the first 9, but that's okay. All right, now are we done?
No.
So why? So we're not solving, we're factoring, but we should always look. Does this piece factor any further?
No.
So I'm just going to rewrite it. The fact that we can't factor it further means it's a what type of expression? If it can't be broken down? Prime. It was prime, so we just came along. Let's look at this one. Now we're back at the beginning of our list because now we have another thing to factor. Okay, so looking at this. No GCF. 5 doesn't go into 4. 2 doesn't go into 25. None. Okay. Is it a binomial? Is it a trinomial? And what do we hope to see? Is it a perfect square? And how do we check? Can you take the square root of this? What is it? 2x. And I'm like, I'm going to do my scratch work above, although I don't normally. 2x. Can you take the square root of this? If you multiply and double, do we get this? We definitely, if we multiply and double, it's not, is it? This would have, so doubled is 20, just so you know. But we would need a 20x, right? So it's not perfect. Well, can you guys find, if that doesn't work, what else could we try? Can you find me factors of 100 that add up to 10? Because I'm trying grouping now. And I'm going to erase this just so you know. But my 100, they have to add up to 10. Well, it's not 1 in 100. It's not 2 in 50. It's not 5 in 20. It's not 4 in 25. 10 and 10 add up to 20. I don't think we can do it. Can't do it. So if we were solving, you might use a quadratic formula. If we're not solving, we checked, could we factor it? Were we able to find those numbers? No, we could use a quadratic formula, but it's also prime. This morning, I do want to caution you with something. This morning, whatever example we did, this one came out to be a perfect square, and we did it 2 different ways. One of them we could keep factoring, the other we couldn't. So keep that in mind. We'll deal with it when we get there. Is this super hard just to use the formula? Now, this whole line, just so you're aware, was me hoping we could factor something further, but we couldn't. So I ultimately just wrote the exact same thing. You don't have to do that every time. It was just I was hoping this one would factor because legitimately I thought it was a perfect square because I was goofed up on that middle term. But it's not. We're done. Done. We have factored. If we needed to do the set equal to 0 thing to solve it, we could, right? What value of x would make this 0? That'd be -5. So when we do this, and this isn't really our problem, and I don't want you to erase anything, but remember, it's like setting that equal to a 0. I would add 5 and divide by 2. It'd be 5 halves. Okay, now that's not our focus. Just the factoring is our focus. I want you guys to do another one for me. On B, I will give you a nicer one here. I want you to factor for me x cubed plus 343. I will leave this table up for you. I'm going to give you guys a head start. I'll come walk around. So if you have questions or you're unsure, you can ask. You guys do a really good job of asking like anytime. But if you're shy, I'm around. I want to answer questions. But let's look. Do you know the cube root of x cubed? It's x. Okay. The sign is the same sign, so it better be plus. Is this a cube? And it's 7. Okay, so we've just identified my a and b, right? So here, now as soon as we have these, the rest of it's a piece of cake. What is this thing right here squared? Good. What's the sign on this next one? It's the only weird spot. It's minus. It switches. And what does these two multiply to be? Okay. And then this very last term is always plus, and we just take this number and we square it. 49. And look at that. We're done. Piece of cake, I hope. Okay. You guys do not have to write down this problem, but we did a problem yesterday as our bell ringer that was like ACT or SAT style math. I just want to show you guys the same thing can apply here. You probably won't know. This is a new example. And again, totally optional as long as you're following along with it. I'm good with it. This is just like ACT math or SAT math. If I wanted 13 cubed minus 12 cubed, is that a super easy calculation? Probably not. But is this the difference of 2 cubes? Could we just automatically apply that identity again? Now, it's nice to see that it happens to work out in factoring. It happens to work when we're doing other stuff. If you are subtracting 2 cubes, regardless of the context, this will work. What's the cube root of the first one? 13, right off the bat. We don't even have to think about it because the cube root of this. Minus, okay, and then help me out here. Do you guys know this number squared? No. It's 169, which means that this one must be 157. So we plus 157 plus, what's this one squared?
Yeah, I thought we were doing 12 times 12.
Don't we do a times b?
Oh.
The 144 that you're looking for will show up, but it's on the end, the b squared. Definitely not 125. 144. Okay, looking at this, what does this one become? Good? And somebody with a calculator, hook it up, because I don't know this number, but it's easier to add than it is to multiply. Okay. So I'm getting there. I have a calculator too. I agree with 470. 1 times 470? Hey, look at that. We can find the difference of two cubes with multiplication stuff. All right. We have one more thing to leave off. I'm not going to give you guys homework. Beatrice, I can give you the assignment now if you want, or you can watch a video tomorrow to get it. I'm cool with either. I definitely was looking directly at her. And yes, I did mean Lucy. Do you want the homework now, or do you just want to watch a video tomorrow to get it? Okay. I'll get it at the end of class, because I'm going to leave us hanging with something. Okay. Did we draw this triangle last week? Do you not that one? Do you remember how it worked? Okay. So check it out. The last little thing, we're just going to get the topic header so that we can start tomorrow. We are going to be talking about really ugly name, but really awesome implications. Tomorrow we'll start class by talking about the binomial theorem. It is the same section. You guys know what binomials are. I think you probably have at least a rough idea of what a theorem is because you've all taken geometry. More than rough. What's a theorem? Something has been done to it. I'm okay with an idea as well. It's an idea that has been, your favorite part of geometry was? It's an idea that has been proven true. Like, that's what a theorem is. So this thing has been proven true. We are not proving it, just so you know. Now, I do want you to do a little tiny stuff. There's no real formal homework, but you're going to help me do a few things. And I'm going to leave room on the left side of my page, or on the right side of my page, rather. But you guys are going to help me do a few of these. If I had two numbers, x and y, or variables, rather. If I did x plus y to the 0, what does it give me? It's not 0. It's not x plus y either. What's 2 to the 0? It's not 0. It's 1. Now, do you know why? Do you understand why, or do you just remember that as a fact? Okay, would you like to know why? This might be what we do instead. Okay, so I'm just going to, and you know what? We'll keep it up here. Because this is 1. And if you're not 100% sure of why that's the case, we should make sure it's clear other than because Mr. Arvis said so. Although I do believe things that Mr. Arvis says, just for the record. Okay, we're going to start with not 0. If I asked you, and everything in white is just us thinking, okay? Like, you don't have to write it unless you want it. We don't know this one. We might, but we want to see what it is. What's 2 to the 1? Now, if I wanted to get 2 squared, could I just use the fact that I know this and multiply by 2? And I would get a 4, right? And if I wanted 2 cubed, could I do the same thing and just multiply by 2 again? And I know it's 8. What if I knew that 2 cubed was 8 and I wanted to figure out what 2 squared was? And I was undoing it. I would divide by 2. And if I did this, I would divide by 2. And if I did this, then I must, well, let's try to divide by 2. If I'm looking at this, if I took this and divided it by 2, I'd have 2 from before divided by 2 is 1. But this idea doesn't stop here. 2 to the negative 1, have you guys dealt with? Have you seen negative exponents?
Only when I was trying to do the science integration.
Okay, so check out how easy this is. All we have to do is take this number and do what to it? So 2 to the negative 1 must be 1 over 2. Now I'm going to write 1 over 2 to the first because that's really what it is, but it's just that. Could I divide by 2 again or multiply by 1/2 again? If I went one further and I divided by 2 again, which is the same as multiplying, it becomes 1/4, which do you guys agree is just 1 over 2 squared? What if I wanted to go further? Without doing all the extra math, what's 2 to the negative 3? 1 over 2 to the, and all of a sudden, we don't have to just blindly memorize the rule. And I don't know, like, if that's what you've done, that's okay. Like, it is fine. But now it's not so much of a remember that this is the case. Just remember that you can do these things without pure, like, actual just memorization. You can work it out. Okay. Later, Raiders. Lucy.